So today we are going to continue our journey with reliability, and we are going today to speak about the failure modes. We had explained in the previous lecture a little bit about it. If you remember, we had started with the jargons or the acronyms of the reliability-centered maintenance information worksheet, which is a crucial part of the reliability-centered maintenance. So it includes the function failure. So the functions, that's what we acquire the equipment for, whether it is a main function or a secondary function. And the function failure is when one of these functions fails. So that's a function failure. It fails to deliver the water, it fails to deliver the material, it fails to protect something, it fails to turn something, it fails to deliver the pressure, fails to deliver the hydraulic oil, fails to rotate, something like that. So it's failed to move. So that's a function failure. And after that comes the failure mode. So the failure mode simply is the cause of the failure. But we need to stress on the failure mode and how many failure modes are good for a single failure or for a single function failure. And what do we mean by modes? Because unfortunately, the word mode is not that common used. You don't, unless you are adopting already the reliability-centered maintenance practices, then or analysis, then you don't use the word failure mode that much. So usually the mode is something different when we come to our daily life. So it's mode, it's moody. So it's in the Oxford language, it said that the mode is the manner in which something occurs, or something is experienced, or something is expressed, or something is done. So that's how something is done, or how something occurs. For example, my preferred mode of transport is a bicycle. So I expressed that my mode of transport, also how I transport, is using the bicycle. So as we say, the failure mode is how the function fails. That's the reason of the failure, the cause of the failure. So why the reliability-centered maintenance has chosen the word mode, not the cause of the failure or the reason of the failure, and so on. It has a lot of reasons, but let's take it mathematically, that if we have a set of numbers, this set of numbers may have one mode, may have more than one mode, or may have no mode at all. It's something random. Okay, no specific mode is available. So if we look at this set of numbers, for example, that's 1, 2, 2, 3, 4, 4, then 5, 6, 7, and 8, 8, and 9, and 0. It has two equally weighted modes, which is the 4, 4, 4, and the 8, 8, 8. So that's the most repeated numbers inside this number set. So that's the tendency of this number set tends toward the 4 and the 8. So it's having two equally weighted modes. That's mathematically expressed, and all the other number exists and valid. So that's if you can make link to it with your failures. So for example, this failure occurs because of this reason and this reason. You can count up to 10 reasons or 10 modes or 10 causes for the failure. But there are 2 or 3 failure modes or failure causes that are repeated most frequently. So that's how the equipment tends to fail. So that's what we mean by a failure mode. That's how the equipment fails. When we retrieve an equipment from failure, so we tend to repair the failure mode. So the reactive maintenance is repairing a failure mode. The preventive maintenance, if we are saying taking a preventive action, so we are preventing a failure, or we are preventing a failure mode from occurring. Okay, so if we say, but we say that the failure modes needs to be specific. So one side, now we understand what we mean by failure mode. It's mainly means the cause of the failure, or one of the causes of the failure, one of the reasons of the failure. And we need also to understand that when we speak about failure modes, we need to be a little bit specific. So when we say that why the cooling water is not delivered, we say that pump failed, motor failed, cooling water stops. All these are very general failures. We cannot consider them as failure modes. A failure mode needs to be linked to a part that will be repaired or replaced, so we can resolve this function failure. So again, failure mode needs to be specific. It needs to be linked to one part or to one point in the equipment that I'm going to repair or change, and based on this repair or change, I'm going to retrieve the operation. So when saying that motor tripped or saying that cooling water stopped, or saying that pump failed, that's very general. Failure that cannot reflect to a specific equipment that I'm going to take action with. So the function mode or the failure mode need to have a specific equipment that I'm going to take action with. If you think about the maintenance or preventive maintenance we are doing, the preventive maintenance is simply preventing the occurrence of a failure mode. So when we're managing the failure, so actually we are managing the failure modes or preventing the failure modes from occurring. Okay, so if we say, for example, speak about a motor, so when the motor stops, the motor is not working in an isolated medium. So the motor stops to many reasons. Circuit breaker trips, cables are having a problem. So some sensor in the field can stop the rotation of the motor to protect some failure. So there are a lot of reasons for the motor to stop. So we need to be specific in when we define the motor stopped, the pump stopped, the pump stopped. So why the pump stopped? Because the motor stopped. Why the motor stopped? Because the pump was overloaded. Why the pump was overloaded? Because the bearing is jammed. So bearing jam, or bearing was having a problem, or coupling was having a problem, something like that, that caused the motor to trip, and that's caused the delivery of the water to stop. So we need to be specific in the failure mode to some part that we are going to repair. So the function of the motor itself, for example, if you take the motor as an example, so we need, when we are doing some maintenance for the motor, so the target is to maintain the motor in operation, but the target is not keeping the motor just rotating. The target is the load that the motor is driving is to continue its function. So the conveyor continues to pump, continues to work and deliver materials. The water pump or the oil pump continues to deliver. The lubrication pump put some lubrication at the lubrication point. So we need the motor, so it's lifting a load, or if it is related to a crane. So we need the motor to continue rotating, so we have the function. So the function failure is not rotating, is not related to the motor failure. The function failure is stopping of lifting the weight. And the motor failure itself is not a failure mode. It's the breaker tripped. And then when we go in details why the breaker trips, then we have a lot of modes for breaking the trigger. Maybe a sensor for overload, maybe a sensor for protection of overspeed. Many things trips the motor and makes the brakes enters. Okay, so we need to understand this. We know that single failure may have many failure modes. Why? Because there are many reasons for one failure. To be able to make the reliability-centered maintenance analysis, we need to reach to the real causes of the failure, which are the real modes of the failure, where I'm going to repair. So the failure mode that I select is the mode that I'm going to repair. It's related to a part, so a sensor, overspeed sensor for lifting crane, stopped the rotation of the motor. So I need to repair the failure, the overspeed sensor, and that's where the failure occurs. I need to repair the brakes. That's caused the slippage, and the slippage caused the motor to break, and so on. So we go to another little bit example. If we can say about the power supply to any equipment. So the power supply, we take as an example, the power supply starts from the circuit breaker that supplies the pump skid, that supplies the series of conveyors. And the circuit breaker itself has many functions. So if we go to the deep details to study the circuit breaker, the main circuit breaker of a pump skid itself, it has many functions. One function is to make on and off, to isolate the electrical power for safety, because we are doing maintenance, for example. Another function is to trip, to protect the part. So if some motor is overloaded or some part of the circuit is overloaded, it consumes current more than its design, it protects its load, it protects the motor from the overload, or protects from the spike in the current. We had one example previously during working, that someone tuned the motor to the full current of the motor while the load was very small. So when the pump was jammed, the pump was completely damaged and was not protected by the circuit breaker and so on, because the motor was rated higher than the pump itself. Also, it isolates the distribution behind this main breaker, or behind this breaker, so it protects the other breakers on the same line feeding other machines, so they do not all fail due to a failure of sub-equipment of this breaker itself. Also, there are the cables between the main breaker and the skid or the conveyor, and there are the local power connections and the sensors for the protection and so on. Every one of these can stop the rotation of the motor, and stopping the rotation of the motor stops the function. So the rotation of the motor, you can drop it from the speaking. So for speed sensor, stopped the rotation. Overload due to jam in a bearing, stopped the rotation. Clocking in one filter, stopped the rotation. For safety, for the wire ropes of the conveyors and so on, someone pulled a wire rope, that's stopped the motor rotation. So that's a failure mode. Not the failure mode is not the tripping of the motor itself. Okay, so there's one question that's very important to understand also about the failure mode. How many failure modes are enough? So too little failure modes is a problem. Too many failure modes is a problem, because if we take too little failure modes, this means that we are micro managing the equipment. So we went to a very detailed part inside the equipment itself that is very specific, and that's why we can find it's 1 or 2 failure modes. And if we have tens of failure modes or reach to 100 failure modes, it means that we used one very general equipment and we didn't distribute it properly. So the important is the quality of the recorded failure mode. So it's the recorded failure mode has some equipment or some action can be taken to prevent or repair this failure mode. I change the pairing, I change the sensor, I repair the sensor, I isolate, increase the thermal isolation. I can make something specific. So that's a good failure mode. A general failure mode where I cannot take an action, or I can take several, I need to take several actions to repair one failure mode, that's of a bad quality, failure mode of bad quality. So we need to make sure of the quality of the failure mode. Then we need to be balanced between the number of failure modes. Too many failure modes, this means that's a very big system we had selected, we didn't distribute it correctly, and very few means that we didn't reach the actual causes of the failures, or we are selecting a very small part, internal part of the system, that's why it trips. Okay, so in conclusion, I hope now you had understood what is failure mode and how it is important to the reliability centered maintenance. If you feel that these words is touching you, you can reach us through our web store, which is on this page. You'll find the links in the description of this video, or you can join our trainings on Udemy. You'll find also the description in the you'll find also the links in the description box. See you in coming videos with more insights about reliability and reliability centered maintenance.